Okay, welcome back to another video on Circuit Maker with the electronic snap circuits project kit. I'd like to be able to show you today how we can build a circuit where you're going to be able to increase your power source by having multiple power sources. That really is what our project is all about. So anyways, I have all the parts in here. I have already assembled some of the pieces, but we're going to start from the beginning. And there's no particular sequence that you need to follow here other than essentially following the proper circuit schematic. Okay, so here we go. What do we got here? We got a 1 kilo ohm resistor, and we got a 3-volt power supply. There's 2 batteries. I'd like to be able to add another power supply, and for that I'm gonna place it right here. I'm gonna use this snapping connection right here, so I'm gonna place that one here. Okay, you see how I do that? Basically press it on the pins and then snap it in. All right, so that's that. I'm gonna just place the components at this moment. Okay. Next, I need to place an LED. These guys have polarity, by the way. So I'm gonna place that light emitting diode right here. Okay. So we got the 2 batteries, we got the resistor, we got the diode, and I am going to place another diode in series right here. This is going to be my second diode. Okay, snap that in. You see how beautiful that. So instead of having wires here, this is perfect. You just snap in the components. I'm going to place a switch on top so that I can control power. And of course, part of what you will do, which I'm going to do, is test out and make sure you got power on this breadboard. So before I do the next connection, which is going to be my connection in here, I'm going to check power on the circuit. And how I do that is I bring my meter, and I'm going to place that meter in DC, right? You can read that DC here. And I'm going to check power at the output terminals of this breadboard, positive, negative. So it looks like I got about 2.5 volts. Supposed to be 3 volts, but that's all right. So these are 2A batteries at 1.5 each, so that should be 3 volts. 2.5. And let's check up here, about the same. So I'm going to have about 5 volts. Okay. And so now what I need to do is make sure that the switch is open. And it is, as you can see here on top. Right, my switch is open. Right, open to the side. I am going to go ahead and snap the other connection point. And then we're going to connect that. So this is a real deal. We're building a circuit, once again, let's review, that has 2 power supplies connected by a bridge. There's a switch that's going to control the energy. There's a resistor that serves the purpose of controlling the current. Another connection point. We have an LED and an LED. Notice that everything has to make sense here. In the sense that, number one, we place the switch right at the positive terminal of the power supply, right? And then the switch is going to control the power going into the resistor. The resistor will adjust the power going to the diode. This is still the most positive side of the diode. This is the negative, we call the anode and the cathode. And this is the positive side of this diode, anode and cathode. And then we go out to the negative terminal of the power supply. So there we have a full circuit that we're just ready to test it out. Here's what happens. When you close the switch, current is going to go from the power supply batteries, which in this case is 2, through the 1K ohm resistor, this LED, then through the next LED, and back to the second group of batteries. And what we're expecting is that both LEDs will lead. The voltage will be high enough to turn on both LEDs when the batteries are connected in series. It's possible that one single set of batteries will not illuminate the LEDs. Some devices use only 1.5 battery, but you can have different kinds of setups. So let's go ahead and give it a shot. All right. And there we go. You can see that, right, if we turn the light off for a second here, you're going to see that the LEDs, you see that, illuminate. Okay, so we're accomplishing our work. These batteries are a little bit down. There we go. Now, with the kind of setup we have, we could also modify this circuit if we wanted to. And how you would modify that is you could possibly remove one of these LEDs. Not highly recommendable, but because I know that the power is low in this circuit, we can get around. I'm going to open the switch, reconnect here, and you see that we got a better result, right? And the reason being is these voltages are low. So again, we got a series set of power supplies, 2 batteries connected to one another, and we can derive a number of things in here from this circuit. One of those derivatives is the fact that when you connect components in series, such as batteries, what you're adding is adding voltage capacity to the circuit. In other words, whatever the value of that power supply plus that power supply, it will be added together, right? And that's what we've demonstrated here. We could also do the same here, eliminating this LED and putting the other one, right? And we could do some more weird things with this, such as we could place these 2 guys in parallel, and they will also be able to lead up. That's another possibility. And I think we got a few minutes. Let's go ahead and do that. So I'm going to turn that off. I'm going to place that in parallel. Oh boy. And I will need another snap that will connect this part right here. Maybe we can. Right? This is not the right way to do it, but anyhow, and we have a series source connecting 2 LEDs in parallel. Oh. Sorry, Siri. And there we go. The second LED is not doing too well, but the first one's still working, so I may need to tweak this a little bit to make it work correctly. But you see the point here, right? We've proven that 2 power supplies can be connected together, and as we do that, we're going to have the effect of the 2 power supplies in the circuit, and we have demonstrated that, right? There we go. So our circuit's working, and we've demonstrated series connection of power supplies. Next, we're going to be looking at batteries in parallel. This was batteries in series. Thank you, with love and enthusiasm, from Dr. O. Thank you so much. See you next time. Goodbye.